Okay, so I am going to go over some things that Alex is saying that you guys need help with. So it looks like these are in the 50 percentile, and then I'll look for other messages that are lower than that. The first one is estimating a decimal, sum, or difference. So let's see what it's talking about. All right, so it's showing the problem is estimate 1125 minus 9.101 by first rounding to the nearest tenth. Okay, so the first thing I want to show you is that the nearest tenth is just going to be one decimal number. So you got 11.3 and 9.1. All right, so we're going to just put 9.1 there. And we're going to subtract. That'll be 2. 11 take away 9 is also 2. So it looks like my answer should be 2.2. All right, so I'm going to show you what your explanation says. Yeah, and it did the same thing. 11.25 goes to 11.3. 9.101 goes to 9.1. And then you just subtract the difference. If we want to show a different problem, let's do it one more time, and then I'll move on to the next one. So this time it says round to the nearest whole number. All right, so I'm looking at 479, and after the 4, there is a 7. So basically, 56.479 is really more like 56.5. So we're going to make this 50. I think it's going to say remain 56, but I'm going to take it up to 57. And then this 34.5 should go up to 35. So before I do that, we're going to subtract. Let me just see what the, normally 0.479, you would look at the 9, the 7, and the 4, but I'm thinking in this explanation, it's only going to look at the 4. So yeah, it wants the 56 because of the 4. It wants the 56 to remain as 56 and not 57. So I'm going to go back and change that. I don't like this program doing that, but okay. So then we just subtract, and we get 6 minus 5 is 1. 5 minus 3 is 2. And then when you look at the explanation, it's 21, as I spoke of. All right. Next problem says writing a mixed number and an improper fraction from a shaded region. Okay. So the shaded region, the first thing we're going to do is look at the improper fraction. Oh, I'm sorry, the mixed number. We have 1, 2, 3 whole numbers. 3 whole balls. But then we have this ball here, and it's cut up 1, 2, 3, 4. It's cut up into 5 pieces. So the shaded part, we have 4 of the shaded pieces out of a total of 5. So this will be considered 3 and 4 shaded out of the total 5. Now the reason I put the 5 on the bottom is because that's how those are the pieces. That's the way it's cut. Cut pieces. I'm going to put that right there. E-C-E-S. All right, so cut pieces. So now, so this is the mixed number. Mixed number. Now I'm going to write the improper fraction is because all of these are in 5s. This is 5, 5, 5. All 5 are shaded, and then only 4 of these are shaded. So that is 5, 10, 15 plus 4 is 19. And then since everything is cut up into 5s, this is my improper fraction. And so that's the thing. You just got to remember that the way that it's cut is the number that goes on the bottom. So I'll do one more. There's your improper fraction. All right, I'll do one more like this. And then let me show another. All right, so this is only cut into 2 pieces at a time. So my bottom number is going to be 2. I'm going to start with the mixed number. I have 1, 2 that are completely shaded. And then out of these 2 pieces, I only have 1 that's shaded. So that's going to be 1 out of 2. So that's 2 and 1/2 shaded. Now, if I look at the number of cuts, I got 1, 2, 3, 4, 5. And each one of those are cut into 2 pieces. So there's my improper fraction. Hopefully that's helpful. Okay, so let's take a look at distinguishing between area and perimeter of a rectangle. Yeah, we've already done this one. All right, so I'm not going to show this. Now, area of a piecewise rectangular figure. I know that this is an issue. Piecewise, okay. So the first thing I want to do is to remind you that when you're looking at a rectangle, you have 2 sides that are going to always be the same. These 2 sides will be the same, and then top and bottom will be the same. So basically what I want to do is cut this, make this a rectangle. So if this is 4 and that's 5, that means this is 4 and that's 5. Oh Lord, I did it backwards. If this is 4, this is 4, because there's a 4 right here, and then this is 5. Okay, then, and I'm going to tell you the reason I'm doing this is because here is a rectangle. And so we have rectangle, rectangle, rectangle. This is 4, this is 5. That means this is 5. And this is 4. This is 5, this is 4. That means this is 5. And this is 4. So basically, if I look at the area of each rectangle, area is length, L-E-N-G-T-H, length times width. I'm just going to put W. So I have a 4 times a 5. I guess it's not going to ask me for, it's not going to ask me for a perimeter. So right now I have a rectangle that has a 4 and a 5 right here. So that's 20. 4 times 5 is 20. Then I have another one just like that right here. So that's saying 4 times 5. So that's also 20. And then I have this one. This part is 3, but if you look at this 4 and that 4, this whole rectangle is actually, this is 3, and I have to add these 2 numbers up. So that's 8. 3 times 8 is 24. Because the length of the first part is 4, and then because I took it all the way down, it's 4 as well. And I didn't have to cut it this way, but I chose to. All right, 20, 20, and 24 is my combined area. And I just add those up, and that's my area. That's 4, and it's 2, 4, 6. So the area here is 64. Now, I'm going to show you on the explanation. Oops. They didn't cut it up my way. All right, so they did it like this. So we have a 3 times 4. And then you have this missing side, but it's not really missing. It's 5, 3, and 5, which is what they did right here. That's 13. 13 times 4, that's not the way I would have gone, because those are bigger numbers, and they don't want you to use a calculator. Then you need to, you need to be able to figure this out quick. So they said we got one rectangle up here, 3 times 4 is 12. Another rectangle down here, 4 times 13 is 52. And when you add those two together, it's 64. Now, if you look at what I said, the way I did it, I still got 64. It just came out differently because I cut it differently. All right, let's show another. Okay, I'm up to 10 minutes. All right, so now I have this rectangle. I'm going to cut it this way. Okay, so let's look at what I have. So I have 4 times 3. I have a 4 and a 3. But then I have this issue right here. This piece, this whole thing right here is 8. And so I got to ask the question, if this whole thing is 8, well, if I cut this part off, and we already see that there's a 4 here, that means this bottom part is 4. So that means this part is 4 as well. So I have a big one on top that is a 6 by 4. So 4 times 3 is 12. 6 times 4 is 24. And when you add those two up, you get 36. 6, 3. And that's your area. Let's see their explanation. Eight. Take away that 4. So you have a 6, 4, and a 4, 3, which is what I did. And you have a 36 square yards. All right, so I'm going to cut this off for now.